So this is the typical example of Google interview question. I have found this question on Leetcode Discussion. You can check the discussion out. I'll provide a link in the description. I am really very impressed with the quality of this question. There are a few reasons for this. First of all, you can expect a question of this caliber in your telephonic round, or you can expect it as one of the two questions in any of the on-site round of Google. There are more to it. So this question is a perfect candidate for you to get a taste of the problems asked by Google. Also, this question is not hard. It is not hard. However, at the same time, it is also not very straightforward to come up with a very elegant solution. This feature makes this question a perfect candidate to be asked in interviews of companies like Google, right? Let's jump into it. So here's your problem statement. It says, find the minimum absolute difference between two elements in the given array that are at least n indices apart. So basically you have been given an array, and in this array you have to find the minimum absolute difference between two elements, right? So you can say, okay, what's the difference between 10 and 15? The difference between 10 and 15 is 5, right? So the minimum difference here can be 5, but let's say what is the difference between 20 and 22? The difference between 20 and 22, the absolute difference between 20 and 22 is 2. So the minimum difference I can see between any two elements in this array is 2, which is 22 minus 20, which is 2. There is a catch. You are not supposed to find the minimum difference between any two elements. The condition is those two elements should be at least n indices apart. So basically, let's see this example. So you are given this array and you are given an n equal to 3. So you can find the difference between two elements that are at least 3 indices apart. That means you can find a difference between 10 and 25. You can find the difference between 10 and 100. You can find the difference between 10 and 105, and so on and so forth till 15, till the last element. You cannot find the difference between 10 and 20 and 10 and 60 because they are not 3 indices apart. Okay, let me also write the indices here. So what are the differences that are eligible? So 0 is eligible, index number 0 is eligible to get a difference from 3, 4, 5, 6, 7, 8, right? Similarly, one element at 1 is eligible to get a difference from 4, 5, 6, 7, 8 because they are 3 indices apart. So 0 and 3 are 3 indices apart. 0 and 4 are 4 indices apart. 0 and 5 are 5 indices apart. So I'll not stretch it too much, but I hope the question is very, very clear to you. So you can find a difference between two elements if and only if they are at least n indices apart. And what you need to return, what you need to give as an output is the minimum absolute difference between any two elements of this array. Before starting to code or before starting to explain anything, I would highly recommend you guys to basically try it by yourself. Just try it out no matter what solution you are getting. If you're getting a brute force approach, if you're getting an optimal approach, if you're getting an approach which might be better than what I'm going to explain you guys, anything, just let me know in the comment section your approach and the time complexity. The main motive of this series is for you to practice, for you to learn something new, and that's why it is a very important exercise that before understanding a solution which I'm going to explain you, at least once you should try by yourself. So do it, pause the video and then come back and we'll discuss the solution. Let's hop into the solution here. What will be the brute force approach of this problem? So let's think about it. I need to find the difference between two elements in such a way difference between the indices of those two elements should be at least n. So what I can do is I can start from the 0th element, and what are the elements I can take the difference from? It starts from 3. So I can have two loops. I will point to the current element, and in the second loop, j will point to the element I plus n, right? So I can take the difference of both of them. So I will point to 10, j will point to 25. Now I'll take the difference. What will be the difference at first? The difference will be 25 minus 10, or absolute of 10 minus 25, anything. So absolute of 10 minus 25, this will be 15. I'll also take a global variable. I'll call it answer. Answer is integer max, let's say, and then I'll find the difference. And there will be a simple condition that, okay, if my answer is greater than, greater than the difference I got right now, then all I need to do is answer will be equal to the difference. This is simple. Now I will keep on incrementing from I equal to the length of the array. Okay, and this I equal to 0 to basically length of the array minus n, right? Because it can go only up to this point. So my I will go till 105, because 105 will have a difference with 15. For 107, there is no element I can get a difference from, right? Because there should be at least a difference of n indices. And when I reach to index number 6, there is no element with the difference of indices of n. This is the brute force approach which we can apply. And now let's see what will be the time complexity of this approach. Because you are using two loops, this is loop number 1 from I equal to 0 to almost n, and from j equal to I plus 1 to array length. So this will become n square. You are traversing twice, the time complexity will be n squared. I'm explaining you in a way that I will explain in an interview. So I'll start with the brute force approach, and then I'll try to see what are the things I'm doing extra work on, right? So I'll write this pointer. So try to think about your extra work. Okay, so keeping this in mind, let me copy this array down here, and let's try to think about what extra work I'm doing. So let's say if I am at this particular element, element 10, okay, I'll call it current. Okay, so my current element is 10. I am looking into all the elements from 25 to 15. So let me write it here. So I am looking for the minimum difference with all the elements here. And I think this is the work I can reduce, right? This is the work I'm doing an extra, I'm putting an extra effort. So how can I reduce this? I have no idea, right? So let's do one thing. What if this array is sorted? Will I be able to reduce my effort or something? Let's try this. My current is 10 again, but this time all I'm thinking about that the elements I will get the difference with is in a sorted order. So let me put them in sorted order. 15 will come first, 22 will come next, and 25, 100, 105, 107, and yes, this is sorted. So what if it is sorted? If it is sorted, I can find the difference of 10, absolute difference of 10 and 15 in the very first time. It will give me a difference of 5, right? And then I'll go to 22 and it will give me a difference of 7, which is greater than that. And okay, and that is how I will make sure that, okay, I don't have to go beyond that. Because if I'm getting a difference which is greater from the previous one, then I can guarantee that the difference will keep on increasing, right? Why? Because all the elements are greater than that. So I'm not going to get a difference which is lesser than what I have already got. Okay, I can reduce my effort here, but I've got my answer at the very first time, right? I've got my answer of the minimum difference with 15 only. What if my answer lies somewhere here, right? Let's take an example. So let's suppose currently I am at a value 103, and again, the same array is in front of me in sorted manner. So if you see, if I get a difference with 15, I'll get a very large difference. The difference will reduce when I come to 22. And because the difference is reducing, I will keep on going in this array. Again, the difference will reduce, the difference will reduce. Here, the difference will be 103 minus 100, which will be 3. Then the difference will be 103 minus 105, which will be 2, because we are talking about absolute difference. And then here the difference will increase. And once the difference will increase, I will say, okay, stop it here. Oh, but what is happening here? Basically, you have traversed over all the elements again, which is again n squared solution in a way, and you are again sorted it, right? So you have done the sorting, put some extra effort, and again traversing over the whole array, which is bad. So let's try to do something. Let's try to do something. I don't want to traverse over all the elements, and I know that okay, 103, there will be a position in here where 103 will fit, right? This is right here between 100 and 105, the 103 will fit. Let me try to visualize this. So what if I fit 103 here? Can you see this? So if you want to find the minimum difference of any element in this array with 103, the minimum difference you can find is from 100 or from 105. Otherwise, the difference will keep on increasing if you go to the left, if you go to 25, 22, 15, or if you go to 107, the difference will keep on increasing. Right. So this is a great intuition. Now, what I can say, find the correct position of the current element. In our case is 103. So let me remove it for now, and let me give the indices here. So if I find the correct position of this, correct position in the sorted array, the correct position will be 4. 103 should sit here, 105 and 107 will shift into the right side. Okay. And if it is sitting here at 4, the minimum difference would be from 100 or would be from 105. So my minimum difference will be minimum of array at 4 minus the current element, which is 103, or 103, because I know 103 is greater than the element which is lesser than where it should sit. So it would be 4 minus 1, which is 3. So my answer will come from here. Either it will be the element where it should sit, which is greater than that, 105 minus 103, or 103 minus 100. And in this case, the answer will come out to be 105 minus 103, which is 2. So the minimum difference will be 2, and I don't have to do any extra effort, any extra work getting the difference from these elements. And this is how I can, reduce the time of my algorithm. Now let's talk about the solution, like how will you eventually do this, and how will you basically reduce your problem. So you want your element in sorted manner. So let's think about this, right? Here, if let's see it in a reverse manner, right? Let's talk about at least n indices apart. So let's talk about 25. When I'm at 25, the only element I can compare 25 is element at index number 0, which is 10. If I am at 15, the elements I can get a difference from would be from 10 to 105. And if these elements are in sorted order, then I can apply my logic, which is the intuition we have discussed previously. How can I keep these elements in sorted order? I can use a data structure, right? I can use a set. So I can use a set. In set, everything will be sorted, number one. Also, the second thing is I want to find the correct position of the current element. This is the upper bound. You are essentially finding the upper bound of the current element. If the current element is 103, you want to find the upper bound of it. That will be the correct position of this element to get inserted into. right? So you can easily find an upper bound on a set. There is an inbuilt function which you can use, or I would highly recommend you to check my binary search playlist. There I have given you guys a wonderful generic binary search solution which you can use to find upper bound, lower bound, reverse upper bound, reverse lower bound. Only a single code you can use for all types of binary search solutions, right? So I would highly recommend you. In the solution which I am going to write, I will use the inbuilt function of C++, C++ library, which is upper bound, which is on set. The set will keep it sorted. You can do the upper bound on the set. And if you are doing all these things, the rest is very simple. All you need to do, whatever the index you will get, you need to find the minimum from any two elements, the upper bound you have got so far, or the element which is lesser than that. Now let's talk about the time complexity of this solution. What are we going to do is we are going to use a set, and set will keep everything sorted, but at a cost of log n time, right? So let's suppose I am at 15 right now, and everything from 10 to 105 is in the set. And if I put everything in the set, for each insertion, it would take log n time. So the total time for insertion will be n times log n. This is inserting into set. Now, what about upper bound? So for each element, I will take the upper bound. When I am at 100, I will take the upper bound on 10 and 20. When I will be at 107, I will take the upper bound on 10, 20, 60, 25. So for each element, I'm going to take an upper bound, and that will again cost me n times log n. So for n elements, I'm going to take upper bound, and each upper bound going to take log n time. So the total time for me doing upper bound for all the element is n log n. The total time complexity here will be big O of n log n plus n log n. That will be 2 times n log n, which is in big O notation, if I say, is n times log n. Okay, and of course, n is being used already in the question. We are saying at least n indices apart. So let's change it to L, where L is the length of the array. So the time complexity will be big O of L log L. Let's come to the coding part here. I'm just writing the structure here. So this is the basic structure. What I'm doing is I have the vector of numbers here. I have got n, and I'm calling this minimum absolute difference n indices apart function, and this function should give me the correct difference, the minimum absolute difference. Okay, so let's start with the code here. So I will say I will just have int answer that would point to infinity. Let's say this integer, maximum integer value, and I will have a which will be nums dot size. I also need a set, right? I also need a set. The set will be set of integers. I'll call it as, you see here. Where will I start? I will start from nth index. Why I need to start from nth index is because then only I would be able to consider the very first element. So I will start from n, and the element to consider will be the I minus nth element. Okay, let me start with the I equal to n. I is less than L, I plus plus. So this is where I will start from, and I will say, okay, the last index which I can consider will be I minus n. This being said, what I need to do is basically I need to insert this element into my set. So let's do this. I will say s dot insert the element at nums of j. Let's think what else do I need to do. So basically in the next step I need to find the upper bound, right? I can say s dot upper bound, and I need to find the upper bound of the current element, right? So let me also write the current element here. The current element will be nums of I. So I need to find the upper bound of this current element. I would pass the current here, and it will give me the iterator of the current element. Now see, there are two scenarios. Number one scenario is, so this is your sorted array, right? If you are finding something which is greater than any element in this array. So let's say you're finding 110. In that case, the upper bound will be nothing. And in C++, the upper bound will give you the end of this set. That means the element you are at right now is greater than all the elements in the sorted array, right? Okay, in this case, I can handle this case easily. So I can say if the it is equal to s dot end, that means I am at the end of the array. Now, if I'm at the end of the array, that means there will be only one element to compare and take the difference from, right? I can call it previous. What it would be? It would be, so I will decrement my iterator and I will take the value of previous one. So what I have done here is basically if I am pointing outside of the array, I have decremented my iterator to the last element and I have took the value of it in the previous variable. Cool. Now let's find the difference. The difference is nothing but the absolute value of current minus the previous. Although if I'll not take the absolute value, that will also work, but let's take absolute for being safe. So, and then I'll update my answer. The answer will be minimum of my answer or the difference. Now let's come to the second scenario, and this is interesting. So now I'm getting some value. So let's say in this case, 103, I will get an index of 4 here. Now all I need to do is I need to find the previous and I need to find the next and get the minimum difference from there, right? So as I said, let's find the previous. Let's find the next first because it is actually pointing to the next. The upper bound will point to the next element, right? 105. So next is nothing but the value of the iterator where you are right now. And what will be the previous? For the previous, all you need to do is decrement the iterator and get the previous. So this time it will be, you have decremented the iterator and you've got the previous. Now let's find out the difference. Now this time the difference will be the minimum of difference of the current element from next and from the previous. Let's take the apps value again for being safe. So I would say next minus current or the absolute value of current minus previous. Okay, and now here again the answer will be minimum of answer comma the difference, right? And all I need to do is when this for loop will end, I will return the answer. I have took care of the situation when I will go out of the array when the upper bound actually does not exist. In that case, the last element of the array would be the greatest one. And if the upper bound exists, then there will be two scenarios to compare, the next and the previous, and I'll find the minimum difference between both of them. And at the end, I'm returning the answer. And now, let's see for this particular scenario, what is the answer I'm getting. Let me run the code. I've got 2, which is the correct answer. The correct difference between, the correct minimum between two elements are 20 and between 20 and 22, which is 2. Now let me increment 22 to 23 and let's see if this difference is increasing. Right now it is giving me 2. Yeah, so okay, now the difference is between 25 and 23, which is 2, right? Okay, let me increment it to 24. Now the answer should be 1 between 24 and 25. Yeah, the answer is 1 and it's coming between 24 and 25. What if I make it 25? Will the answer become 0? Yes, the answer now is 0. So yes, this code is working absolutely fine. You can see how concise and how beautiful this code is, right? It is very much readable. My suggestion to you is always use meaningful variable name, meaningful function name, no matter how big the name look. But it is very, very important for you to explain each and everything to the interviewer when you are giving the interview, right? You should serve your code on a plate beautifully to the interviewer, and that is the only recipe, for the success. So yes, I hope this does make sense. We have already discussed about the time complexity, and this is a really, really beautiful and really, really good interview question asked in Google. And if you're still here, I hope this video is giving some value. And if you want to see more such videos, please consider subscribing to this channel. It gives me motivation. And it takes a lot of time to prepare, to do research, to explain you guys, and I would love to continue that. I just need some motivation from you guys, so please consider subscribing.